CIET NCERT presents audiobook Curiosity, Textbook of Science for Grade 7.
Page number 57, Chapter number 5, Changes Around Us, Physical and Chemical. On the right-hand side of this page, a QR code is provided which can be scanned to access various learning resources related to this chapter. On this page, you will find what different children have observed about the changes happening in daily life. Let us describe them one by one. The first boy says, "I placed a cube of ice here half an hour ago. It has now become water." A picture of melting ice is also provided in the dialog box. Now, a girl is sharing her observation about a rose flower. A bird that I saw yesterday on this rose plant has become a flower today. Another girl adds about a bottle of cold water. The bottle containing cold water is not cold anymore. Finally, a boy explains about a banana. Yesterday, I saw some brown spots on a banana, but today it has more brown spots and a strong smell. These students are describing some changes. What kinds of changes are they talking about? Page number 58. Activity 5.1. Let us think and reflect. You might have observed various changes happening around you. Some of them are listed in Table 5.1. You may notice that something is changing in each case. Take a moment to reflect on the changes in each case. Record your observations in Table 5.1. Table 5.1. Some changes observed around us. This table includes 3 columns and 12 rows. First column is serial number. Second is change. This column lists 11 changes observed in the surroundings. 1. Melting ice cubes. 2. Chopping vegetables. 3. Boiling water. 4. Making popcorn from corn. 5. Cutting a piece of paper. 6. Adding beetroot extract to water. 7. Burning wood. 8. Drying wet clothes. 9. Making small balls of dough. 10. Rolling small balls of dough into chapatis. 11. Any other. Next column is observation or observations, where blank spaces in each row are provided to record your observations. You might have noticed that these changes could be in the size, shape, smell, or other property of the substance or object. Can you think of some other changes that happen in your surroundings? Make a list of those changes too. We observe the changes occurring around us with the help of our senses of sight, smell, touch, hearing, and taste. At the bottom, a picture of girl is given on this page, who is asking, "Can we arrange these changes into categories?" Let us try to answer this question. Page number 59. 5.1. A substance may change in appearance and remain the same. Activity 5.2. Let us create and discuss. A. Creating some objects with paper. Step 1. Take a few sheets of paper and fold them to create new objects, which is given in Figure 5.1. Figure 5.1 is a colorful picture of objects made from paper. At the right side of this page, there are around 12 small paper models made by using the art of folding paper, which are placed on a flat surface. Step 2. Do you get the same paper back when you unfold these objects? B. Playing with a balloon. Step 1. Take a balloon and inflate it. Now loosen your grip and let the air escape out. Step 2. Do you get the uninflated balloon back? Step 3. Take another balloon, inflate it, and grip the opening tightly. Now prick it with a pin. There is a caution message for all. Be careful while using a pin. Step 1. What happens? Will you be able to get the uninflated balloon back? C. Crushing a piece of chalk. Step 1. Crush a small piece of chalk into powder. Step 2. Can you get the chalk piece back from the powder? Is there any similarity in the changes listed in A, B, and C? During all these changes, materials such as the paper, the rubber sheet of the balloon, and the chalk remained the same, though their appearances, shape, or size may have changed. You may also recall the grade 6 science textbook curiosity that water can exist in different states, solid, liquid, and gas, and can change from one state to another. In all these cases, although we observe a change in the appearance, no new substance is formed. Such changes, in which only physical properties like shape, size, and state of substances change, are called physical changes. Let us explore a different type of change. Page number 60. 5.2. A substance may change in appearance and not remain the same. Activity 5.3. Let us explore. Point 1. Take 2 glass tumblers or small transparent bottles. Mark them A and B. Second, fill 1/4 of a glass tumbler A with tap water and 1/4 of glass tumbler B with lime water. Third, now blow air, exhale, into each glass tumbler one at a time using separate straws, which is given in figure 5.2, and observe them. Let us describe figure 5.2, where a picture of a boy standing next to a table holding a transparent glass tumbler filled with tap water. The boy is gently blowing into a straw through his mouth. In figure 5.2b, lime water is used in place of tap water. Do you notice any changes? In glass tumbler A, blowing air into water creates bubbles only, and there is no change in the appearance of the water. In glass tumbler B, blowing air into lime water creates bubbles and turns the lime water milky or cloudy. If we leave it for some time, a white substance settles at the bottom of the glass tumbler, indicating something new has formed. Such changes, in which one or more new substances are formed, are called chemical changes. New substances are formed through a process called chemical reaction. In this case, carbon dioxide from the air you breathe out, exhale, reacts with lime water and forms a new white-colored substance, calcium carbonate, that is insoluble in water. Therefore, the liquid in the bottle appears milky. Along with this, a small amount of water is also formed. This information for a new substance indicates a chemical change. The chemical reaction involved in this change can be represented in short form as a chemical equation. Page number 61. A chemical equation is provided here where calcium hydroxide, when adds with carbon dioxide, gives us calcium carbonate and water. Calcium carbonate is an insoluble substance. The calcium hydroxide which is used in this reaction is also called lime water. The turning of lime water milky is also used as a test for carbon dioxide. Let us explore this with another activity using some substances from your kitchen. Activity 5.4. Let us experiment. Step 1. Take a teaspoonful of vinegar or lemon juice in a test tube. Step 2. Add a pinch of baking soda, sodium hydrogen carbonate, to it. Step 3. What do you observe? Step 4. You would hear a fizzing, bubbling sound and see the gas bubbles forming. Step 5. Pass this gas through freshly prepared lime water kept in another test tube as given in figure 5.3a. Step 6. What do you observe? Step 7. The lime water turns milky. What do you infer about the gas formed by mixing vinegar and baking soda? This indicates that the gas formed is carbon dioxide. This activity can also be performed using 2 small used bottles instead of test tubes and a flexible straw as given in figure 5.3b. In figure 5.3a, the experimental setup of the discussed activity is given. And in figure B, same activity is set up by using 2 small used bottles in place of test tubes. Since a new substance, carbon dioxide, is formed in this reaction, we say that a chemical change has occurred here as well. It can be represented as vinegar plus baking soda gives us carbon dioxide plus other substances. The above activity using baking soda and water. Do you observe any bubble formation? Is this a physical or a chemical change? Repeat the given activity using baking soda and water. Page number 62. 5.3. Some other processes involving chemical changes. 5.3.1. Rusting. In the rusting of iron, which you studied in the chapter The World of Metals and Non-Metals, a new brown-colored substance called rust is formed. Thus, rusting is also a chemical change because it involves the formation of a new substance, iron oxide, which is given in figure 5.4. Figure 5.4 is depicting rusted iron nails. 5.3.2 Combustion. Let us recall the burning of a magnesium ribbon, which is given in figure 5.5, learnt in the chapter The World of Metals and Non-Metals. Can you predict if this is a physical or a chemical change? Figure 5.5, a magnesium ribbon is burning with a bright flame. When the magnesium ribbon is burnt, a new substance, magnesium oxide, is formed. So the burning of magnesium ribbon also involves a chemical change. We observed that heat and light are also produced along with the formation of a new substance in this reaction. The burning of magnesium ribbon can be represented as magnesium ribbon plus oxygen, air, gives us magnesium oxide, which is a white powder, plus heat plus light. A chemical reaction in which a substance reacts with oxygen and produces heat and or light is called combustion. Substances that undergo combustion reactions are called combustible substances. For example, wood, paper, cotton, kerosene, etc. are combustible substances. Let us find out whether the presence of oxygen is essential for combustion. Activity 5.5. Let us investigate. Step 1. Place 2 identical candles on 2 separate petri dishes and light them. Step 2. Cover one of these with a glass tumbler as given in figure 5.6. In figure 5.6a, step 2, cover one of these with a glass tumbler as given in figure 5.6. Figure 5.6a, where a burning candle is kept on a petri dish. Figure 5.6b, where the candle is covered with a glass tumbler. Step 3. What happens to the candle flames in the 2 cases? Page number 63. We observe that the candle that was not covered, as given in figure 5.6a, continues to burn, whereas the candle that was covered with a glass tumbler, which is given in figure 5.6b, stops burning after some time. Why does this happen? Since the candle covered by the glass tumbler does not have a continuous supply of air, the flame gets extinguished soon. The component of air that supports combustion is oxygen. This can be confirmed by the presence of carbon dioxide in the glass tumbler, inverted on the candle. How can you test the presence of carbon dioxide gas? You can test the carbon dioxide gas by adding a small amount of lime water in the petri dish. You will notice that it turns milky. This carbon dioxide was formed by the carbon from the wax and the oxygen from the air. In other words, oxygen is required for combustion. There is an interesting box called Science and Society, which is given at the middle of this page. This box links with the real-life applications showing how science has contributed to societal development. This box reads, if a person's clothes catch fire, what is the best way to extinguish the fire? Wrap a blanket or cloth around the person. This cuts off the supply of air and the fire gets extinguished. There is a question message for you. Synthetic blanket or cloth should never be used to put out a fire, as these can melt and stick to the skin. There is another important box of fascinating facts. This box reads, Nature's Wonders. You might have observed some insects emitting light in a garden or a field in the late evenings. These insects are called fireflies, and their light is produced by a chemical change. This type of light production without heat in living organisms is called bioluminescence. There is a picture of fireflies is also provided. Is the presence of air enough for combustion? We learned above that combustible substances and oxygen are necessary for combustion. We also know that paper is a combustible substance, but we can keep it in the air for any length of time without it catching fire. What else is needed to start combustion? Let us learn about this. Page number 64. Activity 5.6. Let us investigate. A question message. Perform this activity under the supervision of your teacher or an adult. Step 1. Hold a piece of paper with a pair of tongs and bring a lighted matchstick to it. It quickly catches fire. Do we say that we need a fire to start the burning process? Step 2. Take another piece of paper. Using a magnifying glass, focus the sun rays to make the smallest and brightest spot on the paper, as given in the figure 5.7a. Hold it there for some time. Figure 5.7a depicts the focusing of sun rays on a white paper using a magnifying glass. What do you observe? We observe that the paper starts to emit smoke and then catches fire, which is given in figure 5.7b. Figure 5.7b represents the next step where paper is catching fire. Thus, we find that a substance can burn even without fire. How do we explain this change? Focusing sun rays on the paper heats it. The temperature of the paper increases with time. After some time, the paper becomes so hot that it starts burning. This minimum temperature at which a substance catches fire is called its ignition temperature. Since the temperature of the lighted matchstick was already higher than the ignition temperature of the paper, it caught fire almost immediately. So we can conclude that for the combustion process to occur, there are three requirements, which is given in figure 5.8. Figure 5.8, there is a fire triangle. It is a simple triangle that helps us to understand what is needed to start a fire. In the center of the triangle, a symbol of fire is drawn. On each side of the triangle, one word is written over it. These words are: first, heat; second, fuel; third, oxygen. Now, let us describe this fire triangle in details. Point 1. A combustible substance, also called fuel. Second, oxygen. Third, heat that allows the fuel to reach its ignition temperature. So we can understand 5.4. Can physical and chemical changes occur in the same process? What changes take place when a candle is lit? Let us explore. Page number 65. Activity 5.7. Think, pair and share. You may find a figure 5.9. Analyze what students are discussing about the burning candle. What do you think? Figure 5.9. What changes occur when a candle burns? This figure depicts a group of children sitting around a burning candle. They are discussing the various changes happen when a candle burns. One child says the wax melts and evaporates. Another child adds, I think the wax burns and new substances are formed. The third child observes, wax melts, flows and solidifies in different shapes. Another child wonders and says, maybe the wick draws up the liquid wax. And a child is still thinking and says, maybe the wax of the candle melts, is carried up the wick and evaporates due to the heat of the flame. The vapor of wax burns to produce a flame. The melting of wax, its solidification and evaporation are physical changes. The burning of vapor, on the other hand, is a chemical change. This shows that the burning of a candle involves both physical and chemical changes. Now, there is a box which is given at the bottom of this page, Know a Scientist, where students can learn about the contribution of various national and international scientists about a topic from the chapter. This box reads, the candle you just observed has long been an object of curiosity for several scientists, including Michael Faraday, who made significant contributions to several areas of science. In the 19th century, Faraday delivered a series of lectures called Chemical History of a Candle. Faraday believed that the candle was a perfect object to introduce scientific study. Through it, he discussed differences between various physical and chemical processes like melting, vaporization, and combustion. At the left side of this box, there is a picture which is given. This picture is of scientist Michael Faraday. At the left side of this box, a picture of scientist Michael Faraday is provided. Page number 66, 5.5. Are changes permanent? Once something has undergone a change, can we get it back in its original form? Activity 5.8. Let us think. Think again about all the changes that we have discussed or talked about so far. In which of these can we get back the object or substance in the form we started with? Record your observations in Table 5.2. Table 5.2 can changes be reversed. Table 5.2 includes 3 columns and 5 rows and it continues to 12. Column 1 is serial number, column 2 is change, column 3 is the original state can be brought back, yes or no. First row, number 1, there is written melting ice cubes and the answer is yes. Number 2, chopping vegetables, the answer is no. Number 3, boiling water, the answer is yes. Number 4, making popcorn from corn, the answer is no. Now, from 5th onwards, you can record your observations. for this given table. Returning to the original object or substance with which we started shows that the changes we brought can be reversed. For example, when ice melts, it can be refrozen into ice. Similarly, when water evaporates, it can be condensed back into liquid water. However, some changes cannot be reversed since we cannot get the original object or substance back after the change. For example, chopped vegetables cannot return to their original size and shape, and making popcorn cannot go back to its original form. Thus, changes around us could be grouped into those that can be reversed and those cannot be reversed. 5.6. Are all changes desirable? Many useful changes happen in our daily life. For example, the changing of milk into curd, ripening of fruits, cutting of fruits, and cooking of food. All these are desirable changes. Can you think of some other desirable changes happening around you? Page number 67. On the other hand, some changes may be undesirable, such as the rusting of iron or the decay of food during its storage. A change that is undesirable in some situations may be desirable in other situations. For example, decomposition of food can be very useful in converting food waste into compost. Some changes occurring over the years due to human activity can have a long-term environmental impact. For example, the increased consumption of fuels in cars, trains, aeroplanes, etc. is increasing the amount of carbon dioxide in the atmosphere. Drying of paint on walls, doors, furniture, etc. releases many substances through evaporation, causing atmospheric pollution. 5.7. Some slow natural changes. 5.7.1. Weathering of rocks. Have you seen heaps of sand, soil, and stones lying at the base of mountains as given in figure 5.10a? These are called sediments. At the middle of this page, figure 5.10a is representing sediments at the base of a cliff. B. A red sediment layer. How have these formed? These are formed by physical changes that break up large rocks into smaller pieces. Temperature changes due to climatic conditions, growing roots of trees, and even freezing of water within cracks in the rocks can cause them to break. Water or chemicals present in water can also react with the rocks and cause chemical changes in their composition. An example of such a chemical change is given in figure 5.10b. Here, an originally black-colored rock called basalt, which contains iron, has chemically changed to produce a red-colored layer. The red color is a result of the iron oxide produced when the rock surface was exposed for a long time to water or air containing water vapor. These physical and chemical changes in rocks are collectively called weathering, which eventually leads to the formation of soil. Page number 68, 5.7.2 Erosion. Have you noticed fine sand collecting on riverbeds or in lakes? This sand is formed when rock pebbles, soil, and sediments are broken down and moved from one location to another by natural forces like wind and flowing water. This process is called erosion. Erosion during a landslide is an example of physical change. River rocks and pebbles often appear smoother due to the constant erosion caused by the flowing water. When the speed of the water or wind decreases, such as in an ocean or lake, the material transported during erosion settles down at the bottom. These sediments harden over time and become new rocks. Most of these changes take place over thousands of years and cannot be reversed. Now, let us summarize this chapter in a nutshell. Point 1. A physical change is one in which a substance or object undergoes a change in its physical properties and no new substance is formed. Point 2. A chemical change is one in which one or more new substances are formed. It involves a chemical reaction and can be represented by a chemical equation. Point number 3. Combustion, cooking, and roasting are examples of chemical changes. Point number 4. Substances that undergo combustion are combustible substances. Heat and/or light are given out during combustion. Point number 5. The lowest temperature at which a substance can catch fire is called its ignition temperature. Point number 6. Some changes can be reversed and some cannot. Point number 7. Some changes are desirable and some are not. Point number 8. Rocks undergo physical and chemical changes due to weathering to form soil. Point number 9. Erosion caused by flowing water and wind is a physical change. Page number 69. Let us enhance our learning. Before coming to the exercise of this chapter, let us describe an illustration which is provided on the right-hand side of this page. There is an illustration of a boy which is encouraging us to participate in this section. The boy is sitting confidently on a block with a question mark. He is holding a word block named as inquiry. He is climbing a rope, each step shaped like a stone, and has a question word on it. Words like what if, why, when, where, what could, can it, whose, what will happen, what should, why not, what else, how long, which. This picture reminds us to keep asking questions to learn better. Question number 1. Which of the following statements are the characteristics of a physical change? Option 1. The state of the substance may or may not change. Option 2. A substance with different properties is formed. Option 3. No new substance is formed. Option 4. The substance undergoes a chemical reaction. Point A. First and second. Point B. Second and third. Point C. First and third. Point D. Third and fourth. Question number 2. Predict which of the following changes can be reversed and which cannot be reversed. If you are not sure, you may write that down. Why are you not sure about these? First, stitching cloth to a shirt. Second, twisting of straight string. Third, making idlis from a batter. Fourth, dissolving sugar in water. Fifth, drawing water from a well. Sixth, ripening of fruits. Seventh, boiling water in an open pan. Eighth, rolling up a mat. Ninth, grinding wheat grains to flour. 10th, forming of soil from rocks. Question number 3. State whether the following statements are true or false. In case a statement is false, write the correct statement. First, melting of wax is necessary for burning a candle. True or false? Second, collecting water vapor by condensing involves a chemical change. True or false? Third, the process of converting leaves into compost is a chemical change. True or false? Fourth, mixing baking soda with lemon juice is a chemical change. True or false? Page number 70. Question number 4. Fill in the blanks in the following statements. First, Nalini observed that the handle of her cycle has got brown deposits. The brown deposits are due to dash, and this is a dash change. Second, folding a handkerchief is a dash change and can be dash. Third, a chemical process in which a substance reacts with oxygen with evolution of heat is called dash, and this is a dash change. Fourth, magnesium, when burnt in air, produces a substance called dash. The substance formed is dash in nature. Burning of magnesium is a dash change. Question number 5. Are the changes of water to ice and water to steam physical or chemical? Explain. Question number 6. Is curdling of milk a physical or chemical change? Justify your statement. Question number 7. Natural factors such as wind, rain, etc. help in the formation of soil from rocks. Is this change physical or chemical, and why? Question number 8. Read the following story titled Eco-Friendly Prithvi and tick the most appropriate option or options given in the brackets. Provide a suitable title for your choice for the story. Prithvi is preparing a meal in the kitchen. He chops vegetables, peels potatoes, and cuts fruits. Physical changes or chemical changes. He collects the seeds, fruits, and vegetable peels into a clay pot. Physical or chemical change. The fruits, vegetable peels, and other materials begin to decompose due to the action of bacteria and fungi, forming compost. Physical change or chemical change. He decides to plant seeds in the compost and water them regularly. After a few days, he notices that the seeds begin to germinate and small plants start to grow, eventually blooming into colorful flowers. Physical change or chemical change. His efforts are appreciated by all his family members. Question number 9. Some changes are given here. Write physical changes in the area marked A and chemical changes in the area marked B. Enter the changes which are both physical and chemical in the area marked C. For this question, there is a diagram of two circles is given. These two circles are overlapped over each other, like there are three parts A, B, and C. Before coming to the next question, there is an illustration on the left-hand side of this page. In this illustration, there is a smiling girl standing on the lowest step of a rope ladder. Each step above her has a special word written on it. The bottom step says curiosity, the next step says exploration. Above that is inquiry and then discovery. And at the top, the final step says innovation. This picture shows how our curiosity can lead us step by step to new ideas and inventions, just like climbing a ladder of learning. Page number 71. Process of burning a candle, tearing of paper, rusting, curdling of milk, ripening of fruits, melting of ice, folding of clothes, burning of magnesium, and mixing baking soda with vinegar. Question number 10. The experiments shown in figure 5.11a, b, c, and d were performed. Find out in which case or cases did lime water turn milky and why. Figure 5.11a, where vinegar and baking soda are taken in a test tube. The gas formed in this test tube is passed through lime water, which is kept in another test tube. Figure 5.11b. Lemon juice and vinegar are taken in first test tube and the gas formed is passed through lime water which is kept in next test tube. Figure 5.11c. Vinegar and common salt are taken in the first test tube and the gas formed is passed through lime water which is kept in another test tube. Figure 5.11d. Lemon juice and baking soda are taken in first test tube and the gas formed in this reaction is passed through lime water which is kept in the second test tube. Before coming to the next section, there is an illustration on the right side and bottom of this page. Let us describe this. There is a zigzag rope chart which is provided on this page and it is depicting that all the areas like history, art, geography, society, technology and economy are interdisciplinary. They are integrated. So let us do some interdisciplinary exploratory projects in this next section. Exploratory projects. First, write a message on a piece of paper using lemon juice as ink and let it dry. The message will become invisible. Now use a warm iron over the paper or hold the paper over the flame of a candle, taking care that it does not catch fire. The invisible letters turn dark brown as the paper gets warm. Can any of these changes be reversed? Caution message. Perform this activity under the supervision of an adult. Second, we hear a lot of news about landslides and breaking of rocks in hilly regions these days, causing a lot of damage to life and property. Discuss what steps we can take to reduce landslides and rock erosion. Third, observe the activities going on in the kitchen and note any changes that can be reversed. Are these physical or chemical changes? Page number 72. Fourth, yeast is added while baking bread to make it fluffy and soft. How does yeast work? Try and find out. Step 1. Take a small bottle, some sugar, fresh yeast, water and a balloon. Make a sugar solution in the bottle by mixing 2 teaspoons of sugar and a small amount of water. Now add a spoonful of yeast and cover the mouth of the bottle with a balloon. Leave it undisturbed for about an hour. Step 2. What do you observe? Step 3. Carefully take off the balloon, holding its mouth tightly closed and attach it to another small bottle containing freshly prepared lime water. Shake the bottle so that the contents of the balloon get mixed with lime water. Step 4. What do you observe? Step 5. What can you conclude from this experiment? Step 6. Identify all the changes occurring in the experiment and state which of them are physical and chemical changes. Now, the fifth exploratory project. Chameleons, girgits, change color to blend in with their surroundings, and also when they are angry or sense danger, which is given in figure 5.12. There is a picture of chameleon is provided. Is this a change that can be reversed? Explore from the internet or from your school library. Chapter 5 ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Grade 7. Narration: Harsh Priya. Sound recordists: Ekant Vashisht. Production assistant: Surendra Kumar. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.